Welcome to this video on the Automic Automation Ansible Tower integration solution. In this video, we will explain the Ansible Tower integration and what it brings to the Automic Automation user community. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other non-cloud operations. By integrating Ansible Tower, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. Ansible Tower processes can then be synchronized with all other environments routinely supported by Automic Automation, like applications and databases. Ansible Tower's role is reduced to start the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the Ansible Tower environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise them in simple dashboard tools designed natively for operations. Statuses are color-coded and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of Ansible Tower jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple ini file containing standard values: AE system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository, a connection object to store the Ansible Tower endpoint and login data, and a job template designed to trigger start template jobs. Let's assume we're automating 4 instances of Ansible Tower. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create start template jobs in Automic Automation for each corresponding process in Ansible Tower. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in Ansible Tower. We're able to retrieve the successive statuses, supervise the processes in the cloud, and finally generate a job report. In Automic Automation, this start template job can be incorporated in workflows and integrated with other non-cloud processes. The procedure to deploy the Ansible Tower integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the ini configuration files, and several other items like the start command. We use the appropriate ini file for our specific platform. Ansible Tower is a standard Automic agent. It requires at least 4 values to be updated: agent name, Automic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. We create a connection object for every Ansible Tower instance that we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the Ansible Tower endpoint. Finally, we create the start template jobs we need. We match this Automic Automation job to the Ansible Tower start template job, reference the connection object, and run it. We're able to supervise the jobs, generate logs, and retrieve the status. The job can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the Ansible Tower integration. The agent is included in the Ansible Tower package, which we download from Marketplace. We unzip the package, which creates a file system agents/Ansible Tower/bin that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcitx and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the jar file via the Java command. The agent connects to AE and deploys the object templates needed to support the integration, the con or connection object, and the Ansible Tower job template. In our demo, we will create a connection object. Once we have established the connection to the Ansible Tower environment, we'll create a start template job. Finally, we'll execute and supervise the job. Let's have a look at our Ansible Tower instance. This is the templates view. An Ansible Tower template is a definition and set of parameters for running Ansible jobs. This means that a job always runs from within a template. There are 2 types of templates, job and workflow templates. In our demo, we are going to show and run a job template. Here is our job template. A job template always has a playbook. A playbook is a list of tasks that automatically execute against hosts. The playbook contains a YAML file. Let's have a look at this YAML file. The YAML file contains the tasks that the job will execute. In our case, the YAML file has only one task that will print a message saying "Hello World." Let's log into Automic Automation now. We add an Ansible Tower connection object in exactly the same way as any other object in Automic Automation. The endpoint identifies the Ansible Tower environment that we will connect to. Ansible Tower connection objects support 2 types of authentication. The basic authentication requires the username and the password of the user that has the privileges to access the Ansible Tower environment. The token authentication requires the long-lived token that is generated in Ansible Tower. Let's have a look at the Automic Automation Start template job now. In connection, we select the connection object that we have defined and that will establish the communication with the Ansible Tower environment. The organization is the highest level in the Ansible Tower object hierarchy. It is a logical collection of users, teams, projects, and inventories. Ansible Tower job and workflow templates reside in organizations. To select one, we can either enter its name here or click the browser button to open a dialog and search for it. The list in this dialog shows all the organizations available in the Ansible Tower environment that we are connected to. Under job type, we select the type or template that this start job will trigger. In our case, this is job template. This means that we have to populate the following fields. Template ID. This is the name of the template as defined on the Ansible Tower environment. This is the job on Ansible Tower that this start template job will trigger. You can either enter it or you can click the browser button and select one from the jobs dialog. The jobs dialog displays only jobs of the type that we have previously selected. In our case, this is job template. So far, the standard definition fields on this page define the most important job attributes. However, Ansible Tower jobs have more attributes than these ones. If necessary, we can enter additional job attributes in the extra variable data field. We can either specify the path where we have stored the JSON file that contains the additional variables and their values, or we can select JSON and write the variables in JSON format. In the Retrieve Job Output option, we specify if we want to store the event log, which contains execution information from the Ansible Tower environment, either always or only when the job fails. If we leave the job output file path field empty, the event log is stored in the temp folder of the agent installation directory. Finally, we can specify additional output variables that you can use for further processing this job. Let's select the Set Output Variables checkbox. This displays the output variables table. We can specify variables in JSON format. The variables that we define here parse the content of the downloaded event log. We can then use them in various ways. For example, we can add the start template job to a workflow and use the output variables in its post conditions tab. This would allow us to apply conditional actions to subsequent tasks in the workflow based on the content of the variables. If the JSON expression that we define returns multiple values, then we'll get multiple JSONs. We can store the multiple output variables under the same variable name by selecting Use Array. Let's execute the job and see what happens. We open the executions view. As you can see, the job is active. If we refresh the view, we see that the job has completed. Let's open the report. Here we have all the logs. The agent log provides all the status. Let's go back to the execution view. The details pane provides information about the execution, for example, the remote status. This information is updated along the job status on the Ansible Tower environment. This status reflects the exact status of the job on Ansible Tower at any point in time. Let's expand the details pane to see the output variables that we mentioned before. This is what the published output variables look like. We had requested the count and the event data, and here we have the results. Let's see a very simple example of how to use the output variables. We have a small workflow with 2 tasks. The first one is our start template job. We have configured its post conditions to get and publish the count and the success nodes values. The second task in the workflow is a script. Let's have a look at it. This script will print the values of the output variables. Thank you for watching this video.